All right. Thank you so much for joining. I hope you had a great first session. In the next session, Bryn is going to talk about CQL and clinical quality measures, and we will learn about many new words like DEQM, CQL, and so on. So I hope you're excited. And with that, Bryn, the stage is yours.
All right, thank you. All right, I don't see my slides. There. All right, now I see my slides. And then is that clicker working? No. Fair enough. All right, so we'll leave that. All right, so my name is Bryn Rhodes. I'm the Director of Standard Strategy with Smile Digital Health. I'm also a co-chair of CDS and a participant in CQI. And worked on a lot of the standards involved in quality measurement in the HL7 for quite a while. All right, so learning objectives, what is quality reporting? What's a quality measure? What's the FHIR clinical reasoning module and how does it support quality reporting? What are measure type, scoring, and basis? You should know that by the end. And what IGs support quality reporting, and the other use cases that could potentially be hit by quality reporting infrastructure. So we've got a lot to cover, so I'm going to go through some of it pretty quickly. This is a busy slide. Underneath is the quality improvement ecosystem. These are the stakeholders involved in kind of the flow of evidence-based information from research through guideline synthesis to best practice delivery as clinical decision support, measurement and analytics, and back through public health reporting and registries. Ideally, this forms a continuous improvement cycle. And so a big part of that is the quality measurement aspect, where we have reporting specifications for measures, and then we report off of those measures to agencies and organizations that care about the result of that. So what is a quality measure? It's a quantitative tool. There's from the HQMF specification, the definition, a quantitative tool to assess the performance of an individual or organization related to a specific process or outcome. And so you hear the term ECQM is typically applied when we are mostly talking about an electronic specification for that measure, and it's based on clinical data coming from an EHR typically. That's opposed to claims-based measures. Hybrid measures can typically use administrative data as well, and then DEQMs, which are kind of a newer term that you'll hear. Digital quality measures, the idea there is they can draw on data from multiple sources, including potentially patient sources, which I think is a really interesting case. So they're typically evaluated at the population level, but it's important that we can evaluate them at an individual level as well. So in the specification landscape, so you have producers and consumers in terms of the actual data involved. So the producers are the clinical systems that are actually producing data as a byproduct of delivery of care. Consumers then are information systems that care about that data. So these are aggregators or decision support services or payers or agencies. And then you have specifiers that are the organizations that are involved in specifying the quality measures that are being used. So on the left side, you have measures. That's the FHIR measure resource. And that's the resource that we use to actually communicate a quality measure and the definition of that quality measure. And then on the right is the measure report. That's the resource that we use to communicate the result of evaluating that measure for a particular patient or for a population. And those are the main resources involved. Underlying all of that is the FHIR specification. So we're using FHIR not only to specify what the report is, but the actual data involved in the exchange, so the patient data. Then we use CQL to build the logic involved in population criteria. And then we have implementation guides built across that. So there's a quality measure IG that tells you how to use the measure resource to communicate the specifications. The QI core implementation guide that says these are the profiles that the data conforms to that we're reporting on. And DEQM, that's the data exchange for quality measures that tells you how to actually exchange that data using measure reports. So we talk about the use cases that we're trying to hit. Authoring, so development, validation, review, testing of the actual specifications. Publishing, where we have packaging and discovery, publication and distribution of those reporting specifications. And then the actual implementation. So the reporting, data exchange, gaps in care, case management, those are all use cases that we're trying to hit. So if you talk about the components of a measure, there's metadata. So those are things like the identifiers, the narrative description of the measure specification, supporting evidence, the topics involved, governance, relationship to other artifacts, all those kinds of information that you might care about the measure itself, but aren't the actual measure. And then the structure of the measure, like the logic, the population criteria, what kind of measure it is, and then the actual logic. So these are the conditions involved in the criteria. So what are the inclusion criteria for the measure? What are the exclusion criteria? Those are the kind of main components of a measure. So if we look at the measure anatomy, L1 is the metadata. This is typically in the human readable is just presented as kind of a table like that. You just have information about the measure. Then for L2, we start getting into the human readable. So this is the population criteria. Typically, you have like the initial population. We'll get into those denominator, numerator. It's kind of hard to read that, but and then the structure of the measure is in the measure resource, and that's actually saying the numerator, denominator, initial population. And then finally the logic, where you actually have the machine readable representation of the logic so that systems can actually process the inclusion and exclusion criteria for the measure. So those are the things we need to share. And then evolution of quality measurement. Right now, it's in specifications, we typically see HQMF, the health quality measure format, QDM, quality data model as the model, and then QRDA, quality reporting document architecture. That's the current specifications. So we introduced in 2018 clinical quality language to start representing the inclusion and exclusion criteria and population criteria for a measure. And then we started to see actual use of FHIR for the model, but still reporting using QRDA for some systems to be able to do that. What we're trying to evolve towards is complete FHIR specification for quality reporting. So the use of FHIR measure to communicate the specification, CQL to communicate the criteria, and the measure report and FHIR resources to communicate the actual reporting results. All right, so for measure types, you have different types of measures like a process measure that focuses on ensuring a particular process is followed. We have outcome measures that are focused on a particular outcome. Structure measures that focus on a healthcare provider's capacity. And then patient-reported outcome that are focused on actually results from patients. What matters from the specification for calculation of a measure is these four components. So you've got the subject of the measure. Is it based on a patient? Is it a location? Is it an organization? We typically see patient-based measures right now. Then there's the basis, and that's the actual type of the members of the population. So even if you have a patient measure, you might have an encounter-based or procedure-based measure. So what you're actually counting in the measure, the actual members of the population. Then you have scoring. That's the actual method of calculation. We'll get through those. And then you have the improvement notation that determines how to interpret that score. So is that score, is increase better or is a decrease better? So you can have inverse measures. So the measure scoring types, you've got proportion. This is the most common one. It's just a numerator and a denominator. We define the inclusion criteria and exclusion criteria to say whether patients are members of those populations. Then you have a ratio measure, which is the same as proportion. You just can draw from different initial populations. And then you have a continuous variable. So evaluating a particular variable for every member of a population. For example, median time from admission to discharge, where you're actually computing a particular metric for every member of the population. Population criteria types. So for each of the scoring types, we define specific criteria types so that when we communicate a measure specification, implementations know how to take those, run the results of the inclusion and exclusion criteria, and then combine those to actually produce a measure score. So the most common one is proportion measure. These are the diagram. This diagram illustrates the relationships of the criteria for a typical proportion measure. So you have the initial population, then the denominator is a subset of that. You can have denominator exclusions and exceptions. And then you have the numerator that's a subset of the denominator, and then numerator exclusions. All of those, that's just to say that all of the different scoring types use these population criteria in specific ways so that the systems where you communicate a measure specification know exactly how to perform the calculation. And so that measure authors have an easy and consistent way to describe the criteria that they care about for the measure intent. So subject versus basis is one of the important pieces there. And that lets you describe a patient-based measure. That's the typical kind of approach. Where you have individual members of the population are patients. So if your basis and your subject are the same, then your criteria are just true false statements, inclusion and exclusion. But you can also have episode of care-based or procedure-based measures where you can actually count the criteria are expressing lists of members. And that's kind of the key takeaway there, that in the measure, you have both a subject and a basis. The measure structure itself also supports multi-rate calculations. So those calculation components, the subject, the basis, the scoring, and the improvement notation, those can all be specified either at the measure resource level, so it applies to all of the rates that you care about, or you can do multiple rate measures where each component has to specify each of those, or each group specifies each of those components. And that gives you this flexible structure where you can communicate multi-rate measures as well as composite measures that may reference other measures, for example, like a wellness composite. So I have 5 different measures that are already defined, and I just want to put together a composite measure out of each of those. So I can just have a measure resource that points to the existing definitions. So that's a composite measure. So running through an example, so this is U.S. Preventive Services Task Force. This is the 2016 recommendation. Screening for colorectal cancer starting at age 50 years and continuing until 75. So appropriate screenings defined by any of the following: colonoscopy, flexible sonogroscopy, and so on. So we're just going to use that as an example and walk through what a measure specification looks like in FHIR and CQL. So first, I'm going to talk about terminology. This is one of my favorite signs. If we really followed it, I mean, on one interpretation, we would never use elevators, right? Because they might cause a fire. This is just a crash course in measure terminology from in terminology from the perspective of a measure, right? So code system represents a single system of coded concepts. Code system resource isn't intended for distribution. It's just really a description of the code system. Some code systems do contain their content, but not necessarily. Code systems may be enumerated or may have a formal grammar or both. The important point about a code system is that it can be validated. You can always tell, given a code, is it in or out of this code system? It's kind of a base assumption there. It can also have associated properties like hierarchies and grouping. And so for codes in code systems, it's not only the case that it has that meaning, but it may have additional information you can look up. Then a value set represents a collection of codes from one or more systems. It can have a definition and or an expansion. So in the value set resource, you can have the definition as well as an expansion. It's important to distinguish between those two. The definition is instructions for how to build the contents of that value set. How do I construct the members of that value set? It's a definition that may be, well, we'll get into that. That's different than the expansion, which is an explicit listing of the members of the value set. The value set definition can be either intentional or extensional. Intentional means it's defined in terms of an expression and a criteria. So the code diabetes mellitus and all the child codes recursively. That's relying on that hierarchy in the code system to define the codes in that value set. And then there's extensional, where I'm just enumerating the list of codes. Typically value sets that you see in like the value set authority center defined using enumerations. But we're seeing more and more intentional definitions where it's just a description in terms of an expression, and then you expand that based on the rules of the code system. So there are challenges associated with the value sets. This is a versioning challenge, right? SNOMED publishes at a rate that we don't control. And so we have to be able to talk about the version of SNOMED that we care about, because in our value set definitions, we're talking about codes from a code system. And depending on when you expand that value set, you may get different results depending on which version of the code system you used to do that expansion. So it's important to recognize that the value sets that we're using are pointing at a code system, and that's from the talk earlier today. That's an unversioned canonical reference on purpose, because we want to be able to keep the same definition of the value set and allow the code system version to fluctuate with publication. But it means we have this kind of dangling pointer, right? We have this reference that we need to pin down when we actually care about it and want to use it. So one of the ways that we do that is by identifying all the concepts that we care about in the measure in their own kind of library. With the colorectal cancer concepts, for example, a value set of value set definitions here: colonoscopy, CT colonography. These are all of the value sets that we're using to identify concepts that we care about in the measure. All right, so that's the end of that aside. So data elements now. In FHIR, you have base resources that give you kind of this the syntax, but very little of the semantics. There are very few kind of bindings at the base specification level. In order to really get to semantics, you need to define profiles that define what the semantics are for the elements that we care about. And that's really important in the context of a measure, because when we're talking about the logic, we're referencing things and we're making assumptions about what those elements mean when we're talking about them in the logic. So when we use FHIR within a measure, we care about the profiles that those resources conform to in order to make sure that we're getting the same evaluation when we evaluate the same expression. So data elements in FHIR, resources and profiles made up of any number of elements. Each element describes the name, type, constraints like cardinality and invariance about the value, and the binding. That binding is a reference to a value set. So when we are talking about the value sets, those may come through in bindings defined in profiles that we're writing the measure against. So these definitions are independent of a specific patient, independent of location, time, and they're largely independent of related information as well. So here's an example data element in CQL: flexible sigmoidoscopy performed, procedure in the flexible sigmoidoscopy value set, where the status is completed. So this uses FHIR as a data model. This is expressed in terms of FHIR resources. It references terminology in that concepts library, and it establishes expectations for the values, like invariance. So to apply that data element, you typically need to contextualize it. So it can be contextualized in different ways. So as part of a particular encounter or temporally, so to a point in time or a period in time, a location or a setting, a user relationship. These are all different ways that you can contextualize that same data element, so that same profile definition. So for example, we might flexible sigmoidoscopy performed within 5 years. We contextualize it to today and 5 years before today. We might say what the most recent flexible sigmoidoscopy performed is by defining a function that lets us ask for the most recent there. So those are different ways of contextualizing that same data element. And then just note that data elements can be as complex as we want. So has appropriate colorectal cancer screening is a data element that actually indicates whether exists any of those criteria that are in the recommendation. So is there a fecal occult blood test result within 1 year, a fecal immunochemical test within 3 years, and so on. So a data element can be not only like as simple as a single value in a resource, but it can also be a complex computed data element like this. And then here's an example of the colorectal cancer screening using those data elements in that concepts library. So the initial population is just that the age in years at the start of the measurement period is in the interval from 50 to 75. The denominator is the same as the initial population. The numerator is that they have appropriate colorectal cancer screening, and there's an exclusion for active malignant neoplasm or a total colectomy performed. All right, so that's a measure. So now what can we do with it? So packaging, when we talk about how do we share resources like measures, these are canonical resources. So they're resources that are identified by a canonical URL. That URL will be the same no matter what server that resource appears on. So these are special kind of resource within FHIR that we use to communicate things like code systems, value sets, profiles, and measures and decision support rules are also the same kind of resource. And when we talk about authoring those kinds of resources, there's a content development lifecycle that we go through. They're from design time and authoring, we call those computable concerns. Through packaging and distribution, we call those publishable concerns. And through implementation and runtime, we call those executable concerns. And those are all 10 minutes. All right, I gotta go quicker. Those are all shareable. So when we talk about packaging, what we mean is bundling an artifact for use in a particular context, including its components and dependencies. So typically we see FHIR resources like profiles and value sets distributed through implementation guides. But you can also talk about just a package of resources where I have, say, a measure and all of the libraries and value sets that depend on it. And I use that bundle to actually push that content around. The package will come with different capabilities. So does it have computable, meaning it has the definitions or the raw CQL, or does it have executable, meaning it has an expansion and the actual compiled CQL? And does it have all of its components and dependencies? There's metadata. So there's informal and formal metadata. The informal is things that are like identifiers and description and categories. Those are things that are typically supplied by the authors, whereas the formal metadata are things that enable systems processing, like classifiers, dependencies, data requirements. These are things that can typically be inferred from the definitions. So there's generated content that based on that formal metadata, we can build out. So there's structured content like the dependencies, the data requirements, and then there's also narrative generated content, which is like the human readable. So we use the liquid templates in the publisher to actually build out that human readable. All of that there are build processes that we use to actually generate that content. So you can input the raw resources And then through refresh tooling, we can generate that structured content and that formal metadata. And then we run that through the publisher, and it actually publishes it all or packages it all up as an implementation guide. So that refresh tooling is going to translate all the CQL. It's going to refresh all the generated content. It's going to bundle test cases and measures, and it's going to optionally post those bundled targets to a target server. So for the library resource, for example, the raw input is just the identity and lifecycle and the informal metadata and the CQL. Then the refresh will come through and actually generate that formal metadata, so the data requirements and dependencies and the content. And then the publisher will come through and actually add the narrative. And what you get in the published implementation guide is a complete resource. So that same process for measure includes that formal content. We then can use the measure bundles as a way to communicate between, say, an authoring environment like the MADI or MAT, and then refresh that bundle to get the actual value sets that are coming with it. So let's talk about then a repository. So another way that we can actually communicate these resources is through an artifact repository. So right now, you can think of, or there are terminology services like VSAC and Entrepro that enable value sets to be distributed in an ecosystem. So we've defined as part of the quality measure IG knowledge repository so that the measure content can be communicated in the same way. So in the same way that we have an ecosystem for value sets, imagine a place where you can have measures in that same place. So authoring along the left side, authoring stakeholders can then publish to that ecosystem, and consuming and evaluation systems can then pull from that ecosystem. So that knowledge repository deals with things like the artifact lifecycle, the identity, the versioning, the different kinds of operations that can be performed against it, and the capabilities. So we define an asset collection that allows us to specify, to pin down those unversioned references. So we have a set of measures that all use the same set of value sets, and those value sets reference code systems. And those code system versions are unversioned in the value set definitions. So we need a way to say, when you're using this value set as part of this measure package, use this version of the code system. And that we call a version manifest and communicate as part of that package. Other uses are data requirements. So determining the data and dependency requirements for a particular element. There's an actual operation you can perform against the knowledge repository to say, what data do you actually require in order to get a successful evaluation of that measure? And that'll return a module definition library with that. So here's, for example, the measure narrative. So this is what the publisher will produce based on that measure definition we've been looking at. You can see it just includes the CQL as written, but for each expression that's actually used by the measure. And then here's a data requirements example. So those flexible sigmoidoscopy performed and performed within 5 years are data elements that then have data requirement that's communicated in the measure resource. So it's a structured thing that says, I've got a procedure and they conform to this profile. I reference status and performed elements of that. And so I know that if I am communicating that, I need to send that information. And then I've got a code filter that the path is to the code element and the value set is that colonoscopy performed there, or flexible sigmoidoscopy performed. And then the status is completed. So that's a structured representation of that data element in a way that systems can know what data they need to provide. So in talking about, I've got a few more slides. So the scenarios that for implementation that data exchange for quality measure supports are intended not only to support reporting on a quality measure at the end of a measurement period, but communicating the information throughout the the measurement period. So there's a submit data and a collect data that lets you actually exchange the data incrementally as you go through the period. What that means is that our use cases aren't only retrospective in terms of quality reporting at the end of a period, but we can support use cases like gaps in care and case management. Regardless of the use case, the workflow steps are basically the same. We have the setup, the attribution, and then submission and evaluation. So data exchange with DEQM, we define the submit data, where we're taking the measure, the data required for a measure and submitting that. A collect data, where you're actually asking a server for the data of interest for a measure. And then subscription, that one's under development, but that would support subscription-based exchange. So there are 3 different reporting scenarios. You've got individual reporting, summary reporting, and patient list. Patient list is still under testing, but the idea is that you have a set of patients, and for each patient in that, you're communicating their individual results. So individual is at the patient level, and then summary is population level. For individual reporting, we define the individual measure report profile, and then we expect to use within DEQM a specific organization and then measure profile for that. Summary reporting, this one typically just includes the counts. You might have summary data for like stratifiers and supplemental data as well, but you're not communicating the actual data involved, you're communicating the results, and that's a summary report. And there are also some default profiles there in DEQM. All right, so the way that this is implemented, you may have CQL ingestion, where if you have a system that understands the measure specification and can evaluate the CQL, you can just import or ingest that measure specification, and the system will actually run that. You may also have service integration, where if you have the clinical reasoning implementation, then you call out to that, and you can import the measure into that clinical reasoning implementation, and that's called via service. Either way, that quality measure evaluation will run by running through the CQL expressions and then accessing the data through a data provider. So the key there, and in terms of the use cases that are supported, is that the incremental data collection that we define in DEQM supports things like gaps in care, public health hospital reporting, chronic disease surveillance, through the same measure specifications and infrastructure. So it's kind of a whirlwind. So what did you learn? Hopefully, quality reporting, quality measure, what's the FHIR clinical reasoning module and how it supports quality reporting, what are measure type, scoring, and basis, and then the IGs that support quality reporting, and what are some other use cases. So during DevDays, you can find and reach me in these places and Q&A.
Thank you so much, Bryn. Any questions?
How do you expect, so in the slides that you showed the authoring, the distribution of knowledge artifacts and then the consumption of those artifacts, do you expect that to be centralized, federated? Are there any approaches that you would expect there?
Let's go. All right, so you're talking about, yes. Right now, we're seeing mostly just repositories that have mostly CRUD and then some implementation of like the data requirements operations. But the repository might be a single point for a publisher. It might be a feed where you're getting things like IG publishing feeding into that. And it may be federated as well. You might have like a service that understands different, has different feeds itself and can actually federate. So depending on like your particular subscription or the content that you care about, like an actual knowledge broker type scenario.
So it could be the same thing as terminologies, but we know that there's a server hosting SNOMED and another one hosting my local terminologies, and you have to figure out how to distribute those knowledge artifacts.
Right. It could be this. We already have, there's actually a federated terminology client defined in the tooling to support exactly that, like based on your canonical, which server do you prefer for that? And you could do the same thing with measures. So, or any canonical resource, really.
All right. Any other questions? Mario.
Thank you, Bryn. That was a whirlwind. For us non-techie, non-clinical folks, you're talking a lot about the clinical aspect of clinical quality measures. May I ask, what about the technical components? What about versioning? We heard Graham talk about versioning. One of the things we're always asked at the industry level is, when can we deprecate DSTU2? When should we deprecate R4 in favor of future versions? And when we have changes to IGs and changes to some of the things going on, does versioning play a role? Is there technical components to the CQM where we can look at how much is coming in from various versions of resources? Just curious.
Yes. Yes, very much so. This data requirements operation does exactly that. So each of those dependencies will specify a version. So it's one of the things that we've been working on for a long time in quality measures, because we've always had that case where we have a set of measures that are published. They have value set definitions that reference code systems that are published on different cycles. So versioning has always been a really important and hard problem in measures. And we've solved it there by saying that the value sets that you use should be expanded with a particular set of code system versions. And that definition of what those code system versions are in the current specs, we call it a binding parameter specification. And so that when you release a set of measures, it's coming with that set of versions that you're pinning. We don't actually pin it down in the value set definitions. Otherwise, you'd have different value set versions for every release. If nothing else changed, you don't want to just increment like that. So.
For USCDI version 1 versus version 2, will you be able to extrapolate based on the clinical quality measures? How many are at version 1? How many are at version 2 of USCDI?
Of the measure specification, certainly. I mean, when you're writing a measure, you say what version of the model you're using to actually write that logic. So you'll see like using QA Core 311 or using US Core 311, and it'll actually specify the version. And when you run this data requirements operation, what you get back when it says the model dependency is this version. So if you've stated the version in the measure, it will come through in the dependency. If it's unstated, then you use a version manifest to pin it when you release it. So
we have time for one more question. Otherwise, we end a bit early and we have a bit more break.
Yay, more break.
Okay, thank you so much, Bryn.
All right. Thank you.
And clean Willie were in love.